Okay, so it looks like we may have found significance from what we saw in the other videos. But just as a review, we're not really trying to prove things, right? So starting off, we have our null hypothesis. And in this particular case, the null hypothesis is what's average, what's normal, what's status quo, and nothing special is going on between these two groups, as opposed to the alternative hypothesis, which is the same as our research hypothesis. And in our particular case, we were saying that, Mercy College students have a higher IQ than the rest of the population on average. And that did seem, by the number that we had, to be the case. However, we are not trying to prove this. We can't prove that. We're trying to decide whether or not this is real. So the focus on the hypothesis test is really on the null. This is where our focus is. It's not on the alternative. Now that may seem like, counterproductive or counterintuitive, if you would. You could think of it along the lines of a court case. You're not trying to prove someone is innocent. You're trying to see if they're guilty or not guilty. So if someone is found not guilty, that's not saying they're innocent. That's just saying that they were not found to be guilty. And that's sort of what's going on with a hypothesis test. So in our particular case, we're looking to see whether or not the null hypothesis seems to come across as true. Now, again, just in reviewing it, we said we had, with Mercy College, with our Mercy College sample, we had an N equaling 100, and we found the mean, which I believe we said was 103. And when we did the z-score, comparing it to our known population, we found a z-statistic that equaled 2. And when we did the comparison, we looked at the level of significance of, let's say, 0.05. Well, the decision rule gets made at 1.65, and 2, a z-score of, or a z-statistic of 2, is greater than a z-statistic of 1.65. It's further from the mean than the 1.65. So it's looking like that this might be the case, that our research hypothesis might be accurate. But again, we don't word it that way. We put the emphasis on whether or not the null is true. And again, we can't even look at that. So we have to say, are we going to reject the null hypothesis? And if we reject the null hypothesis, what that means is we found significance with our results. That seems to be a significant result. Based on, of course, an alpha, let's fix that a little bit, an alpha of 0.05, which would mean that our decision rule gets made at 1.65 is where we're going to find significance. And this is further away, so it looks like we have significance. And if we do, we reject the null hypothesis. But let's say this wasn't the alpha that we set, and this wasn't the decision rule. Let's say the alpha that we set was at 0.01. Yikes. That would mean that the decision rule, or the cutoff point for our z-score, would have to be 2.33. Now, we didn't quite, if we have a z of 2, we didn't quite make it. So we don't have significance at a 0.01. In which case, if you don't have significance, you're not going to reject the null, because the null seems to be the case. But you're not going to say, yep, we accept the null. Nope, because the null might be wrong too. We're not sure. So we have to fail to reject the null. So if you don't seem to find significance, you're going to fail to reject. And I get it. The language here is involving negatives, and it's sort of almost like a passive voicing, so that can get a little bit confusing. Think of failing to reject. If I accept something, well, then I failed to reject it. Did you reject it? No, I failed to reject it, meaning I'm going with that. So, again, trying to keep it straight, if we seem to have significance, we're going to reject the null. If we seem to not have significance, or we didn't reach significance, then we're going to fail to reject the null. Now, in this particular case, with the data that we were looking at in the example that we had, yeah, it looks like we're going to reject the null. Now, we might present that based upon an n of 100 and a mean of 103, comparing it to the population at large, which is a mean of 100 and a standard deviation of 15, we're going to reject the null. Mercy College students seem to be smarter than the average person. However, we might be right, but we could also be wrong. The same way, let's say we're going to go with this level of significance, and this again is still our z statistic. Well, if that's the case, then again we're going to fail to reject the null. And we would say, yep, based upon a sample of 100 with a mean of 103, a significance level of 0.01, it seems that Mercy College students are not brighter than the average, so we're going to fail to reject the null. We could also be wrong there. And if we're wrong, well, that could lead to problems. Okay, so let's look at the possible outcomes of the research. Like we were saying, we were trying to see if we had significance or not. Now, in doing this, like we said a few minutes ago, there's a couple of possibilities. First, we're going to reject the null hypothesis because we think we found significance. So if we did, then we're going to reject the null. If we didn't find significance, then we're going to fail to reject the null. Now, that's based upon our significance level. But there's two possibilities with the null. One possibility is that the null is true. The other possibility is that the null is false. So looking at this as a grid, there's two options we're going to have based upon whether we find significance. We're going to reject the null, or we're going to fail to reject the null. And as far as the null itself is concerned, there are two possibilities. The null is true, or the null is false. So let's start with the combination of the null is true, and we're going to reject it. Well, in that particular situation, the truth is there is no difference between these two groups. The research concludes that there is a difference. So truth is there's no difference, but our research conclusion says that there is a difference. If that happens, you have what we call a type 1 error. Not so good. Now let's take a look at another way of looking at this. Let's say we reject the null and the null is actually false. Well, in that case, the truth is that there is a difference. And our research has concluded that there is a difference. In which case, that's known as a type B correct decision. And that's a good thing. Now let's go to the bottom half of the chart. This is where we fail to reject the null. Right? So we did not find significance. Now if we did not find significance and we fail to reject and the null is true, well, the truth of the situation is that there is no difference. So between these two groups, there is no difference. And our research concludes that there is no difference. In that situation, we have a type A correct decision. The last combination is where we find no significance, so we fail to reject, but the null itself is actually false. So in that particular instance, the truth of the situation is that there is a difference between these two groups. The research that we did concluded that there is no difference between these two groups. In that particular situation, we have what you call a type 2 error. Now, neither a type 1 nor a type 2 error are things that you actually want. One is a false positive, if we're talking about medical terms. The other would be a false negative, if we're talking about medical terms. So you do not want a type 1 or a type 2 error. So it's statistics, and we deal in probabilities. What is the probability of having a type 1 error? So I'm just going to write this in here like the mathematical way we would express it. What's the probability of a type 1 error? And then what's the probability of a type 2 error? So what are the probabilities? How likely are you to have one of these two errors, which you don't want? Well, the probability of a type 1 error is the same as your alpha. So whatever you set your alpha for, that's also the probability of a type 1 error. And if we're following the logic along, and if you're still with me at this point, you probably already know that the probability of a type 2 error is actually your beta. So keeping that in mind, probability of a type 1 error, which is not good, is actually alpha. The probability of a type 2 error is beta. So using this, you can then assess what's the risk of a type 1 error, a type 2 error. In our particular case, our research found, based on what we were looking at, that there is a difference. All right, so we're looking at there is a difference. So we're going to reject the null. So we're either going to have a type 1 error, there is a difference we found, there could be no difference, or we could have a type B correct decision. We found that there is a difference, and if the null is indeed false, and we're rejecting the null, well then we would have a type B correct decision.